This is Laura Key. This is for Lab 4, I believe. And this is my discussion thing over my article I had to do for my protein. And I decided to make it into a PowerPoint so that way I wouldn't really forget the information that much. And so my protein was the immunoglobulin G antibody. And the article I chose was titled IgG Subclasses and Allotypes from Structure to Effector Functions. And there was actually 3 authors. There was Jester Vidarsson, Gillian Diekers, and Theo Risbens. It was researched in Amsterdam at the University of Amsterdam. So some background information that they had on the article was there are 5 immunoglobulin isotypes, sorry about that. And the IgG is the most abundant in human serum. And there's 4 subclasses. There's IgG1, IgG2, IgG3, and IgG4. And each subclass has different effector functions. And it accounts, the immunoglobulin G antibody accounts for nearly 10 to 20% of plasma protein, which that's a decent amount. And the antibody responses. So the IgG4 deficiencies are typically rare to see, but they could happen. And all of the other subclasses for the IgGs, it's not really rare to see deficiencies in those. Those kind of happen a lot. And nearly 5% of the normal population has elevated IgG4 levels. So if you do the math, 5% is kind of a big deal to the population. So for the structure, it consists of 4 polypeptide chains. And within those 4 chains, we have 2 identical heavy chains and 2 identical light chains. The 4 subclasses show 90% homology in amino acid sequences with differences that are not randomly distributed. It occurs to be in a Y shape if you look at the 3D structure, and as it's forming into the 3D structure, it's always in a Y shape. And it has inner chain disulfide bonds. And this is my citation for my article that I chose to do this presentation on.